Assalamu alaikum, my dear students. How are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NIEBS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, District. Today I am going to take a physics class for class 10 students. My dear students, our today's topic, Chapter 10 CQ3 from Chapter 10 CQ3 and extra CQ1. Today's lecture number 6 and SW number 5. My dear students, let's start our class. In our previous class we have already discussed CQ1 and 2, and today we will discuss CQ3, then extra CQ1. Now CQ3, see the statement first. Charge Q1, that is 2 coulomb, Q2 minus 1 coulomb, and Q3 is 1 coulomb plus 1 coulomb. So Q1 is plus 2 coulomb, Q2 minus 1 coulomb, and Q3 is given here plus 1 coulomb. Are three charges. These are the three charges placed on a straight line sequentially and equidistant from each other. So question number A, what is electric force? Question number B, why are electric field and electric field intensity not the same? Question number C, draw the lines of force produced by three charges. Question number D, what should be the magnitude of charge Q1 be so that the charge Q3 not feel any force on it? Explain. My dear students, question number A, we have already learned this definition. What is electric force? The force by which two charged objects attracts or repel each other is known as electric force. The force by which two charged objects attract or repel each other is known as electric force. Question number B, why are the electric field and electric field intensity not the same? The region around a charged particle or object within which a force would be exerted on other charged particles or objects is called electric field. And on the other hand, the amount of force exerted or a unit positive charge when placed within an electric field is known as electric intensity of that point. So therefore it is seen that electric field means an area, but electric intensity means force. So for this reason electric field and electric intensity are not same. Now come to question number C, draw the lines of force produced by the three charges. My dear students, this is easy question answer. Here given see this one is the first charge, that is Q1 equals to 2 coulomb. See, suppose this one is 2 coulomb first charge, then the same distance, it will be same distance, and sequentially it will be Q1, it will be Q2, that is it will be minus 1 coulomb charge. Okay, it will be Q2, and another charge, suppose this one is plus 1 coulomb charge, that one is Q3. Okay, now you have to draw the lines of force. Now we know that same charge, this is plus 2 coulomb and this is minus 1 coulomb, that is they are different charges, and we know that different charges always attract each other. So we know another rules to draw the lines of force, that one is plus 2 always diverge these lines of force, and minus charge always converge the lines of force. So the figure will be like this. The lines of electric force goes there, and the direction will be like this. Okay, and here we know that plus charge always, positive charge always diverge the lines of force. Okay, diverge the lines of force. Okay, so it will be like this. Now here the positive positive charge to plus 2 charge, and here is plus 1 charge, that is this is the charge is charge value is larger, that's why the lines of force will be more. Okay, now minus charge and plus charge, that means these charge also different, so they also attract each other. So it will be positive charge always diverges the lines of force. So it will be like this. Direction will be here. Okay, and positive charge diverges the lines of force. So direction will be like this. Okay, my dear students, I hope all of you have understood. This is very easy question answer. Now come to number D. What should be the magnitude of force Q1 be so that the charge Q3 will not feel any force on it? Explain. Here given, see the first charge Q1, Q2 and Q3. Okay, now given that Q2 equals to minus 1 coulomb charge and Q3 is plus coulomb charge, and distance between Q2 and Q3 is x. Suppose this distance between these two charges is x, and so the distance between charge Q1 to Q3 it will be 2x. Okay, 2x, because the distance is equal. And if Q1 dash is replaced by Q1 dash is replaced by Q1 dash, net force on Q3 will be 0, and therefore the force will be exerted by Q1 dash, and Q2 dash on Q3 is equal to 0. So from Coulomb's law we can write this equation. From Coulomb's law we can write this equation. We know that Coulomb's law F equals to K Q1 Q2 divided by R square. Okay, so for charge Q1 and Q3 we can write this equation. F equals to K Q1 means Q1 dash, and Q3 that is Q2 means Q3 dash. Okay, for charge Q1 and Q3 we can write this Coulomb law, then R square, and we know the distance between Q1 and Q3 is 2x. Okay, so 2x whole square. And again we can write for the charge Q2 and Q3 we can write F equals to Coulomb's law, K equals to Q2 divided by Q3 divided by x square. Okay, we can see that here two forces equal, so we can write K Q1 dash Q3 divided by 2x square equals to K into Q2 Q3 divided by x square. So here K square vanish. We can write Q3 also vanish. So we can write Q1 dash divided by 2x whole square equals to Q2 divided by x square. Now square and square also vanish. Sorry, it will be 2x whole square, that means it will be 4x square. Okay, 4x square and equals to, and now this x square and x square vanish, so Q1 dash divided by 4 equals to Q2, and now put the value Q1 dash divided by 4 equals to Q2, means here Q2 is here minus 1 coulomb. Okay, so if we take the side change it will be minus, so minus 1 coulomb minus 1 coulomb, so minus and minus it will be plus. So 1 coulomb, so Q1 dash equals to 4 into 1, that means 4. So the charge of Q1 dash equals to 4. So the charge of Q1 dash equals to 4. So if 4 coulomb charge is placed at Q, charge Q, number force, no force will act on Q3. My dear students, I hope all of you have understood this calculation. Now come to question number extra CQ number 1. Here given picture C here. Point A, C and point B. At point A here given plus 40 coulomb charge, and at point B here given plus 20 coulomb charge. The distance between point A to point C is 18 centimeter, and point C to point B is 6 centimeter. Now charges A and B are placed in the air medium. Question number A. What is electric potential? Question number B. 220 volt to 60 watt is written in an electric bulb. Explain the meaning. Now question number C. Find out the amount of force acting between the charge A and B. We have to find out the amount of force acting between the charge A and V. And question number D, if a unit positive charge is placed at the point C, for which charge the intensity at C will be greater, explain mathematically. My dear students, question number A, electric potential, we have learned this definition. We have already learned this definition. Now question number B, 220 volt to 60 watt is written in an electric bulb. Explain the meaning. This is important question answer. The meaning of 220 volt to and 60 watt on the surface of a bulb is, if the bulb is attached with 220 volt potential difference, then the bulb power will be 60 watt, or it will spend electric energy at a 60 joule per second rate. So my dear students, learn properly this question answer. This is important question answer. Now question number C, find out the amount of force acting between the charges A and B. Charge A and B, between these two charges we have to find out the force. So my dear students, we have written here that charge placed on at point A is Q1 is 40 Coulomb charge, and charge placed on point B here is Q2 is plus 20 Coulomb charge, and distance between this 18 centimeter plus 6 centimeter, that means total 24 centimeter, and we will convert this centimeter into meter. So we have to divide with 100, so it will be 0.24 meter. Now Coulomb constant, we know that C equals to 9 into 10 to the power 9 Newton meter square per Coulomb square. So we have to find out the force now, and we can do this mathematical problem easily. See here, if we know F equals to C or K, Q1 Q3 divided by R square. Here F equals to, we know K means 9 into 10 to the power 9 into 10 to the power 9 divided by Q1 here given 40 Coulomb into Q3 given 20 Coulomb. Okay, 20 Coulomb, sorry, it will be Q2. Okay, and R distance is 0.24 whole square. Okay, by doing this calculation we can find that 1.25 into 10 to the power 14 Newton. Okay, my dear students, now number, I think all of you have understood this calculation. Question number D, if a unit positive charge is placed at the point C, for which charge the intensity of C will be greater, explain mathematically. My dear students, this type of question answer is very important. Question is very important. See here also given charge placed on point A is 40 centimeter, charge placed on point B is Q2 is 20 centimeter, charge placed on point C here, suppose this one is plus 1 Coulomb charge, and distance between A and C 18 centimeter. So if we convert this centimeter into meter, it will be 0.18 meter, and distance between point B and C 6 centimeter, in meter it will be 0.06 meter, and Coulomb constant, that is C or K, equals to 9 into 10 to the power 9 Newton meter square per Coulomb square. My dear students, we have to find out the electric intensity. Okay, electric field intensity. So intensity at point C, intensity at point C for the charge placed on point A, we know this formula here, E equals to, we know this formula, electric field intensity E equals to C or K Q1 divided by Q divided by R square. Okay, Q divided by R square. Okay, suppose you can write this distance on D also. Okay, now put the value, just K means 9 into 10 to the power 9 into 40 divided by Q1 means 40 divided by distance 0.18 whole square. So by doing this calculation we can find this value 1.11 into 10 to the power 13 Newton per Coulomb. Again we have to find out at point C, intensity at point C. So we can write E2 equals to K or C Q2 divided by R2 square. Then we can put the value, and we can easily find out this calculation, 5 into 10 to the power 13 Newton per Coulomb, like this. You can do this calculation like this one. Okay, so from this calculation we can see that E2 is greater than E1. That means the intensity of point C at point C for the charge placed on point B is more. Okay, my dear students, I think all of you have understood our today's topic. This our today's SW number is 5, and your today's SW is CQ3. From CQ3 number D is your SW, and this CQ from this extra CQ1 also question D is your SW, and submit the SW regularly. See you again in the next class. Allah Hafiz.